Hey guys! So here we are with a couple extra examples of predicting products. Just a reminder, here are the steps that we're going to go through. Determine the type of reaction that's taking place. That's going to give us a hint of what the after the arrow stuff should look like. Write down the cations and anions present in each of the reactants with their oxidation numbers. So we're going to rewrite them with their pluses and their minuses. Swap the ions to build our products. Make sure that we combine the cations and anions so that the charges balance, and crisscross our numbers. So remember, cations cannot bond with other cations. They will bond with an anion, or they will stay alone. Anions may bond with another anion if there is a second one available. If not, they will create a molecule with another atom of the same type. So hydrogen could bond with chlorine, but it could also stay by itself and become H2. Final step is balance the chemical equation. So we're going to go through all those steps together. So we have nickel chloride and ammonium sulfide. So step one is determine the type of reaction. Since we have a compound and a compound, this is actually a double replacement reaction. After our arrow, we should have two complete compounds. Step two, list our anions and cations with their oxidation numbers. So if I reverse crisscross this 2 back up, nickel has an oxidation number of +2. Chlorine has an oxidation number of -1. NH4, if I crisscross back up, has an oxidation number of actually -1 because it is an anion. And sulfur has an oxidation number of -2. So after the arrow, what we're going to end up doing is flipping out this second element. So sulfur is going to come over here, and chlorine's going to go where sulfur is. So I'm going to rewrite this for step 3 with the new partners. So Ni has his +2, and S has its -2. NH4 has a -1, and Cl has a -1. Now crisscross those numbers back down, and I'm going to rewrite the whole thing. We have NiCl2, that's the original, plus NH4, 2S yields. Now crisscross these down. If we drop 2 2's down, those actually cancel out, and we have NiS. And if we drop 2 1's down, we do not have to write either of them. So we have NH4 Cl. Now in order to balance NiCl, NH4, and S, we have 1, 2, 2, and 1, 1, 1, 1, and 1. So in order to balance this, I have to put a 2 in front of NH4Cl to change both of these to a 2. So that's our first example, a double replacement reaction. On to our next example. We have sodium nitrate and lead oxide. So step 1 is determine the type of reaction that this is. And since I have 2 compounds, that means this is again a double replacement reaction. Step 2, write the up top numbers. So since there are no down low numbers, NO3 is actually one of our polyatomic ions. We can write that Na has a +1 and NO3 has a -1. NO3 is on our cheat sheet, and it is a -1, and Na is in the first column, so it's a +1. Now the second compound, when we look down low, there are no subscripts. What that means is that they are either 1's or they are the same. So since lead is a transition metal, I cannot look at him to figure this out. I have to look at oxygen. According to the periodic table, oxygen wants to have an oxidation number of -2. Since there is no number next to lead, that means that those numbers had to have been the same, so they canceled out. So lead is going to have an oxidation number of +2, and O is -2, because that's what the periodic table wants it to be. Now that we've written the oxidation numbers, I'm going to rewrite the front. I'm going to write my yield sign, and I'm going to switch my endings. I'm going to flip-flop these after the arrow. So I have Na with a +1, and an O with a -2, and PB with a +2, and NO3 with a -1. Now I'm going to crisscross down my numbers. And Na gets the 2, and O gets a 1. Pb gets a 1, and NO3 gets a 2. Now we can balance Na, NO3, Pb, and O, 1, 1, 1, 1, 2, 2, 1, 1. So I'm going to put a 2 in front of NaNO3 to make these balance. Okay, we're going to do one last practice problem. So Na plus MgO. So since I have a lonely element and a compound, this is going to be a single replacement reaction. That means that after the arrow, I'm going to have a different lonely element and a new compound. Step 2, write your oxidation numbers. So Na, we have to find him on the periodic table, and he's actually in the first column, so he has a +1 oxidation number. Mg is in the second column, so his oxidation number should be +2, but O's should be -2. So since there are no down low numbers here, that means that we canceled those out. So we have a +2 and a -2. Then we're going to switch the ending, so our negative ion is going to come over here and pair with a new partner. So I'm going to rewrite that on the right. So we have Na with a +1 and O with a -2 plus Mg with a +2. So now I'm going to rewrite the very beginning, Na plus MgO with no changes. I'm going to crisscross down these two values. So Na gets a 2 and O gets a 1. And then we're left with magnesium. Even though he has an oxidation number of +2, magnesium is a metal. He does not want to bond with any other metals, so he will not bond with another magnesium atom. Instead, we're just going to list him like normal and not put a number down low. Just like sodium on the left, magnesium is going to be all by himself on the right. So now we just have to balance Na, Mg, and O, 1, 1, and 1, 2, 1, and 1. And I'm going to put a 2 in front of Na to balance those out. So this is another example of a single replacement reaction where we actually have an element swooping in and stealing the ending of another element. Keep in mind, we're going to see a lot of double replacements, some single replacements, and some synthesis reactions. The rest of them I'm not going to make you do in class, but you may be required to do them in college. So double replacement, 2 compounds switching their endings, single replacement, 1 element swooping in and stealing the ending of another, or synthesis, 2 individual elements combining into 1 compound after the arrow. Those are the examples that I'm going to expect you to be able to do. So I'm going to see you in class tomorrow so we can continue practicing on this and hopefully get it down.